Welcome to Cilk++ Training Module 1. I'm Charles Leiserson. I'm the Chief Technology Officer at Cilk Arts. When we look at trying to address the multi-core software revolution and the problems that it's raising, there are three things that come up that need to be addressed. The first is development time. Okay, how do you get your product out in time? Where are you going to find the programming talent? And are you going to be forced to redesign your application? The second is software reliability. Okay, how do you make sure that the code you're developing is reliable? And in particular here we mean race conditions. Okay, and how do you test it effectively before release? And the third, of course, is the reason you go to multi-core to begin with, is application performance. And in particular, minimizing response time as opposed to throughput. And making sure your solution scales so that you can write it once for multi-core, and then as the number of cores increases, you don't have to keep rewriting your application. So we call these three attributes, the development time, software reliability, and application performance, the multi-core software triad. And it's the goal of the Cilk++ system to address all three of those concerns. When you get the Cilk++ system, it comes with the following things. You basically get some documentation, including a quick start guide, reference documents, examples, and this training, such as what you're listening to now. In addition, there is some software that you get, because it wouldn't be as good just to get documentation without the software. In particular, you get a Cilk++ compiler, which is based on the Microsoft Visual Studio, or GCC, and you use that to compile your Cilk++ source code, which is almost identical to your original C++ program with a couple of keywords in it that extend the language to be Cilk++. You're then able to run your program on the Cilk++ runtime system using Cilk++ libraries, and that therefore can produce a software module that you can redistribute if you wish. In addition, there's several tools that Cilk++ offers. One is a race detector we call Cilk Screen. There's performance analysis, and there's debugging integration into the various debugging environments. And you can run on Windows or Linux. Now, the way that the Cilk system works is, just to overview it before we dive in, is as follows. The Cilk++ source is the same as the C source. And you can see the first aspect of the system is that we have keywords that we've embedded into the Cilk++ source, in this case Cilk Spawn and Cilk Sync. And if you remove those keywords, you end up with what we call the serialization of the program, which is a C++ code that implements the same thing as the Cilk++ code. That software you can run through the Cilk++ compiler, which uses the conventional compiler, either Visual Studios or GCC. We then link in hyperobject library, produce a binary which runs on the runtime system. The runtime system is what does all the load balancing and makes it so that your code runs fast. Now, very important is the debugging strategy that we use. So in many parallel environments, as soon as you make it parallel, you're in the situation that you have to debug parallel code, even if you make a trivial serial type of error, okay, such as an array-bound error or whatever. In Cilk++, our strategy is to factor the parallel correctness from the serial correctness. And the serial correctness can be tested just by going via the serialization to run your regression tests, or alternatively, to run it through and run it on a single or multiple processors, okay, to test the code. So either running the Cilk++ or the C++ serialization produces a correct, you check to make sure that it does all the right stuff. For parallel correctness, you're worried about whether you have any race conditions. And for that, we have a race detector, which operates very much like the way you would test ordinary code. You run a set of regression tests against it, and it makes a promise as to whether, it promises that if there's any races in your code, it will find them. And then the last component is the hyperobject library. The hyperobjects are a technology which we'll talk about today, which allow you to deal with the problems of races on global variables without having to drastically restructure your code. So the typical workflow for developing an application is to start by compiling your serial C++ code and running regression tests to verify correctness. So there's step one really should be step 0, I guess, because that's normally where most people start. Step 2 is to identify where are your performance bottlenecks, because there's no point in trying to parallelize something that is already fast. Then you apply the Cilk++ keywords to expose the parallelism that's in your application, and then you compile and run the serial regression test to verify that your code is still correct with the keywords that you've inserted. Then you compile and run the Cilk screen to verify the parallel correctness or locate races. So the Cilk screen will either say you on this particular input that it's race-free, or it will point you to where the races are. If there are races, then you have to solve them, potentially using Cilk++ hyperobjects. And then you go back to 4 and recompile and so forth. Okay? And then finally, when you've done that, you can go identify some more performance bottlenecks and you can iterate. And of course, this is a never-ending process because your code's never nearly fast enough. So the outline for our talk is today is going to be to take a look at the Cilk++ keywords, to look more closely at what we mean by serial correctness, to understand what races are and how you verify parallel correctness, how to cope with non-local variables, and then what are reducer hyperobjects and how do you use them, and then we'll wrap up.